confidence interval for the true population proportion is going to be this value here. Okay, so it's going to be 0.7 minus 0.0187, that should be a 7 there, okay, times our z, okay, which is less than our true population proportion, which is less than 0.7 plus 0.0187 times our z score. Now we've just figured our z score to be 1.96, so this becomes 0.7 minus 0.0187 times 1.96 must be less than pi, our true population proportion, which must be less than 0.7 plus 0.0187 times 1.96. Now when we work this out on the calculator, what we'll do is we'll just do this factor here first of all. It's the same or in both cases. So it's 0.0187 times 1.96 gives us a value of approximately 0.03665. So this becomes 0.7 minus 0.03665, or to 4 decimal places is 0.0367, must be less than pi, must be less than 0.7 plus that value, plus 0.0367, okay, which gives us a value of, well, we have 0.7, or let's say 0.7, okay, minus 0.0367 gives us a value of 0.6633, must be less than pi, must be less than, well, when we add this onto this, it gives us 0.7367. Okay, so really, what does this mean? Well, this means this. It means that the true population proportion, okay, the true population proportion, okay, is bounded below by 0.6633 and is bounded above by 0.7367. And what we're saying is this, is that we're 95% confident. We're 95% confident, okay, that the true population proportion can be found within those two bounds. But let's just keep in mind that it might not be there, okay? It just actually might not be there, and actually might be out in the tails, okay? But we would expect that we would only see the true population proportion out in the tails 5% of the time, okay? And that's our interpretation of actually what a 95% confidence interval is actually telling us. It's giving us a lower bound and an upper bound. It's giving us a lower bound and an upper bound for where we feel that the true population parameter might reside, okay? But let's keep in mind that it might not be in there, okay, and actually it might be outside it. But what we're saying is, in the long run, we would expect to find it 95% of the time between them two values, but we'd also expect to find it in the tails 5% of the time. So that's the first part of this question done. Okay, we've just constructed a 95% confidence interval for the proportion of all construction workers meaning the true population proportion, who received minor injuries over the past year. Now, the next part of the question says this, is based on the confidence interval, is it likely that at least 60% of all construction workers received minor injuries over the past year? Okay, so is it likely, okay, that at least 60% of these construction workers received minor injuries? Okay, now what is 60%? Okay, 60%, okay, if we think about it, okay, 60% is 0.6, okay, so 60%, okay, 60% is a proportion of 0.6, okay, that's the proportion here, okay. So is it likely that at least 60% of all construction workers receive minor injuries? Okay, that's our population proportion, okay. That's the population proportion that we want to estimate. Is it likely that the population proportion, okay, pi, is 0.6? Well, where is pi? pi, in this case, the 0.6, the 60%, okay? Well, 60% is actually less than 0.6633. Okay, 60%, okay, is actually in this particular tail here, okay, if that makes sense, okay. So 60%, okay, 0.60, okay, 0.60, okay, is in that tail here. Now what we're saying is this, is that we're 95% confident that the true population proportion, okay, is greater than 66%, and less than 73%, or it's greater than 66% and less than 74%. They're the bounds that we've put on the true population proportion. This is probably a little bit unusual the way this is saying at least, okay? Maybe we should ask the question, is there evidence to suggest that the true population proportion is 60%, if that makes sense? Now, what we're saying here is this, is that if the true population proportion is 60%, well, this falls outside the bounds of our confidence with respect to this particular interval. So what we're saying is that there's no evidence to suggest that it's 60%, okay? The evidence would suggest that it's actually the true population proportion is actually within these particular bounds. Okay, guys. Once again, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and I hope that this video, another video in our series of videos dealing with confidence intervals, I hope that this video was in some way helpful and intuitive for you. Okay, and once again, thank you for watching. Okay, bye bye.